And we're going to go ahead and dive right into our next panel, which is about urine processing startups. We have an exciting list of folks to hear from. We do have a little bit of a shift, I think, in the order, so I'm going to just voice that out, especially so that the presenters know when they're presenting. So we're going to start with Jenna, and then Nadège, and then Orion, and then Abe Noe-Hays and Kim Nace, and then Julien Saludas. So that's going to be the order. So be ready out there. And so this is really exciting that we get to have an entire panel around urine processing startups, that there's enough happening out there that we need an entire panel for it. And something that we're really excited about at Rich Earth is really holding in our minds how we can, how all these different startups can be supporting each other as this is a new and emerging field. And it's relatively unknown. And I think we all connect with the idea that it's really important that we can build credibility in this space. And so that's just something that's on our mind as we get to hear from all these exciting startups of how are we supporting each other and how are we collectively strengthening the credibility of this movement and of this science that we're excited about and that we firmly believe in and that we're working on. So we'll go ahead and get started. A reminder to go ahead and put in the chat who your questions are for, and for folks in the room at the end we'll have questions and you can go ahead and line up here if you have one. I know a lot of you are also alive in the chat as well, which is great to see. And just a slight shift to that, I believe that Nadège has a time constraint. So after Nadège's presentation, we will have a short amount of time for questions.
Sorry for that. Thanks loads.
Was that Nadège? Okay, great. But we'll go ahead and get started with Jenna Senecal. Jenna is a bioresource engineer and completed her PhD at the Swedish University of Agricultural Sciences, where she co-developed a urine stabilizing and drying technique. Jenna is now leading the commercialization of the technology through Sanitation 360. And it looks like you're all set up. I'll go ahead and mute myself and you're on, Jenna.
Great, thank you so much. So last year I presented more about the tech that we work with and how the technology is working, the chemical stabilization, and I also shared some of our field trial results. This year I'm going to present more on the urine processing as a business, and I put in sort of because we're still pre-commercial and we're dependent on soft funds in order to operate. And so I'm going to show how we're working and where we're trying to get to, and also end with some of the barriers and challenges that we are facing. And so overall, the presentations that have led up to my presentation have been awesome, because it's addressing a lot of the pains that we're feeling in our startup. So last year when I presented, we're 3 people. These are the co-founders from where we developed tech at Swedish University of Agricultural Sciences. And now I can excitedly say that we've expanded the team and looking to expand further. And in terms of a quick overview of how our process works, for us, we need a stabilizer. So the stabilizer needs to mix with the urine as fast as possible so that we can stop the process of urea changing to ammonia. You'll hear from Nadège after me, and in their process, they want everything to change to ammonia. So this is one way where our systems are different. We have a chemical stabilizer that alters the pH, either very high or very low, and then we can work with any type of urine diverting toilet, flush or dry, or urinal. Once the urine is stabilized, it goes into our urine drying system. At the moment, we both have on-site systems where we have urine being treated directly underneath the toilet, and we also have a mobile system, which I'll explain a little bit more. We concentrate the urine 25 to 30 times by removing the water, and then it goes into a pelletizing machine. This is not the pelletizing machine we have now. Last year, we used a meat grinder, which was not very effective. It was very labor intensive, but this is a system that we're looking into. And if anyone out there has experience with pelletizing, I'd love to chat and hear more. We're investing in that type of system now. But we did succeed in producing our pellets, and we achieved 15% nitrogen for this year's field trial, which was very exciting for us. And this is the equipment that we've been using. So it's a seeder where the barley and the fertilizer go directly in, and then there's air tubes and discs that then bury the barley and the fertilizer together. So this is a miniaturized version so that we can do smaller field trials, but it also enables us to test how well our pellets are working with the conventional farming equipment, as the goal for us is to produce the fertilizer where there is no barrier for the farmer to be able to use it directly. This is the business model that we're working with. We have the Swedish university where we have our IP, and then we have Sanitation 360, which is based on Gotland, which is in the middle of the Baltic Sea, and then we have our chemical stabilizers. So we order in different chemicals, we do the blending, and we also order supplies in order to build our own dryers and also some subcontracting. Right now we work with Touchdown. They're a local toilet rental company. So they dispatch these toilets, and we put the chemical stabilizer in before they're sent out. And then we also tested using an insert in the blue chemical toilet. It didn't work so well, but we're hoping with some modifications we might be able to still use it. And we saw an example yesterday in Karsten's video in Germany with a company there. So I'm intrigued to learn more about their system. And then I come along with my truck and a pump, and I collect the urine, and then it comes to our first stage of drying. Right now it's in my garage where we have solar cells providing the electricity. But I'm excited to say that we just got confirmation last week that we can actually work with a cement company that has an incredible amount of waste heat. And so we will be connecting their system. They already have a pipe existing, so it's very easy. So we're building up this trailer as we speak, where we can start drying in January. And so when it's concentrated 25 times, then it gets down into what we call the cookie dough phase, where we add in a binding material, the final drying stage, and convert it into pellets. And this is where we're looking for collaboration. And then all the fertilizer that we're producing is then used to grow barley. And all of this barley then goes to Gotlandsbryggeri, which is a local brewer. And then you can see here, this is from our beer tasting in June of this year. And so then the green you see are financial flows. So Gotlandsbryggeri will buy the barley from the farmer. The farmer will eventually buy the fertilizer from us. At the moment, thanks to our Peter Green project, there is no financial flows at the moment other than for us buying things that are not our official partners. And the value of the fertilizer, we will be selling it at market cost for what the farmer would be buying regular fertilizer for. So the production cost of our fertilizer is more than what we can get back for it. Another way that we see making money is Touchdown has to pay the municipality to dispose of the waste that they collect. So instead of paying the municipality, we can get that disposal cost. We see that that business model is quite tight. There's not a lot of room for us to come in, and it's very labor intensive with all the driving around. But thankfully, with some of our other projects with the soft funding, we are exploring more having permanent installations and for on-site treatment, where I would still need to drive around, but I would only collect liquid concentrate, and then it would go straight, instead of having to do the drying in this system, it would go straight into the cookie dough phase. So that's a little bit of where we are with the business model. And the lucky thing that we see is that the environmental aspect is catching notice. So we are getting a lot of soft funding, both from the Swedish national level, but also the EU level. But when we talk to potential investors, we've never officially opened for bringing in or opening up for investors, but we pitch just for practicing. And we always get that we're too much of a risk. There's too many partners, too many things that we're trying to change, that it's hard for them to see the future of their money coming back. So that's a little bit of a challenge that we see. So we just learned about another type of financing just earlier this week called social impact bonds, where it's investors that want to help create change, and the interest rate can be as low as 2 to 5%. So I share that because it's news to me, and I'm starting to look into that direction as well. I think it could be something for us. If you want to know more, you can reach out. I end with talking a little bit about the challenges and barriers. So I talk about collection at source, treatment, reuse, acceptance, and financial incentives. And I forgot to set my clock, so just interrupt me if I'm going over time. For the collection at source, we see that there's a lot of systems on the market, which is great, but we also see that there's development needed. There's relatively low acceptance. I think it might be a Swedish thing. You guys can tell me, but the men, we don't have many female urinals. The ones that we do dispatch are not being used. So we've tested the LAPI, but they're not being used very much, even if we put screens around. And the male urinals, the crosses, even if we put screens around, put up signs, they're not being used. But I hear from other events that urinals are being used. So maybe it's a Swedish thing. And the other feedback we get is that the urine diverting toilets are too expensive, and there is no financial incentive to put one in. So it's difficult to motivate it beyond our pilot projects that we get the soft funding for. We see it really hard to engage other companies to invest in these types of systems. In terms of the treatment, ours is in development. We have a few other nutrient recycling treatments in Sweden that are also at different phases of development, so more is needed. What we see as the main hurdle is that there's too many questions and unclear responsibilities that we've brought up a little bit in the previous presentations as to who's going to maintain it, who's responsible if someone gets sick, what happens if the whole system breaks down. And so those are red lines that we're trying to get over. And we think that now with the PETA Green project, which is an EU-based project, and some of our other projects, that will have bigger showcasing, and we'll be able to get some of these answers more clearly laid out, and then it'll be easier for then the next group to take it up. Again, there is little to no financial incentive to invest in such a system. In terms of fertilizer, we see that it works well. So we had no difference between the commercial fertilizer and our fertilizer this year in our yields, and we are super happy with our yields with barley. As I said, we're still developing the final product with the pellets. Acceptance is really high with the farmers. Also, through doing on-ground surveys and interviews, people are genuinely interested and open to using it. The challenge is that we're still too small volumes, and then there's no financial incentive to change over to it. So there's this was supposed to be, I was hoping to have some green on this to show that things are in the more complete section, but there's still a lot of work for us to do. So those were the challenges and barriers. And I have one request. We have a survey that is, we're looking for people to answer. I've already put it in the chat. It's part of our PETA Green project, especially those of you who are based in Europe. It would be super great if you can answer it, but any answer from anywhere in the world is also helpful for us. So you can go ahead and scan this QR code if you have your mobile phone with you. Otherwise, it is in the chat. And with that, I'd like to say thank you.
Thank you so much, Jenna. That was amazing. It's always so interesting to you know, it's easy to feel like we're in a little bubble, and then to hear someone having a presentation from so far away and a whole different world and dealing with the same, you know, the same kinds of questions and findings and things is always, you know, weirdly comforting. So we're going to go ahead and move on to Nadège de Chambrier. Nadège is an environmental engineer from ETH Zurich. After different projects on the decentralized sanitation during her master's degree, she worked on a project to develop a mobile urine treatment plant at Vuna. She co-founded VunaNexus during the summer 2022. She's now responsible for technology development and project management. Looks like you're all set up. Take it away.
Thanks for the presentation. Hi, everyone. Let's hope it loads now. Yes. So I'm going to do an update on where we're at VunaNexus. It's probably going to be a little bit more project-based than what Jenna presented, because last year I presented already the business model and those kind of things. So I wanted to go in and show what has been done since last year. As a short reminder for those who were not there last year, what we do is that we use bacteria to treat the urine, to transform it into a concentrated fertilizer, but which is still liquid. And while doing this, we remove all the pollutants that we don't want. Our process is completely automated, and it's partly patented. So how it works, we usually install our systems within a building at the lower stage of the buildings, where we have a storage of yellow water or urine. We usually use either, so the users use either urinals or flush toilets, but our system works as well with dry toilets. As Jenna explained, what we want in our system is to have a urine that has been transformed, so that has ammonia in it. And this type of urine is not stable, but we stabilize it within our biological reactor. In these reactors, we have bacteria, good bacteria, which transform it with the help of air. So in the air, you have oxygen, and they use this oxygen to transform the ammonium to nitrate. In the end, the liquid that comes out of here doesn't smell like urine anymore. We don't consider it urine anymore. It looks like urine, but it's not anymore. It's stable, it doesn't lose ammonia anymore, and it doesn't smell. At this stage, part of the pharmaceuticals that are in urine already have been removed by bacteria. But in order to remove it completely and fully, and in order to do a fertilizer that is safe to use also for food, we added an activated carbon filter, which really removes hormones, antibiotics, and that kind of things that you can find in urine. So that's this next step, this activated carbon filter. After this, we have a concentration step, which also is a hygienization step. So we basically pasteurize. So we heat up the liquid. By this, we concentrate it. So that's a distiller, basically. And on one side, we will have here, as you see here, so we will have the concentrate, which is our fertilizer. It's about 15 to 20 times concentrated compared to urine. And we call this urine. And then on the other side, we have distilled water, which can be reused, for example, for flushing the toilets within the building. So we really close the loop. With this system, we have the advantage of managing to recover all nutrients and not have a loss of nutrients during the process. And we really have a product that does not smell at all. For the nutrients, we have not only the macronutrients like NPK, so nitrogen, phosphorus, and potassium, but also other micronutrients that are really useful. That's usually the case for urine fertilizers, and that's a big advantage compared to fertilizers that can be found on the market. A quick word on the fertilizer itself. So there isn't a big update compared to last year. We are still working on the label, on the permit for France. It's quite complex because Europe doesn't allow to have urine as an entrant for fertilizer in general. So it's a lot of steps to go through, but we are close to it, and hopefully we will manage to have this authorization by the end of the year or beginning of next year, maybe. We already have a step in Europe through Austria. Since Austria is very close to Switzerland, they have very similar rules, and so they basically, if Switzerland accepts it, then they accept it as well. So it makes sense. France is a bit different on that sense, in that direction. Going into the different projects, so one of the main projects that we have or systems that we have installed is at the EAVAG, which is a research institute, which is the place where basically the technology was developed originally. And you can see down here, that's what the system looks like now. The new update is that we installed a new distiller system this year. It's quite big and it's much more energy efficient than what we had before. And in this building, we treat about 400 liters per day. So that's a system that we still use kind of as a pilot because we update it regularly. The next project, which is a quite big and important one for us because it's a big flagship, is the European Space Agency headquarters in Paris. So the ESA, what is called the ESA, is similar to the NASA for the US, but it's the European equivalent. And EAVAG and ESA have been working together for a long time on developing solutions for nutrients in space. And so they have been working with us for a long time as well to help develop the technology, to research the technology as well. And so now they upgraded their headquarters building, and we are installing the system right now. Basically, I'm going next Monday to finish it and to commission it. Yeah, it's a small system, but it's an interesting one because it will be useful for many people in France who are interested, and they'll be able to go to Paris, which is very central for everyone, and to be able to see how it looks. So that's a short overview of how it is. It's not completely finished yet, but that gives you an idea of the room. So at the back you have the urine storage, and then here in the middle you see the reactor, so where the bacteria is doing its thing. And then in the middle, there isn't there on the picture, but there will be the activated carbon filter. And then here will be the product storage. I think the circular bar project, probably for those who were yesterday online, you saw from the video from Karsten, so I'm not going to go into too much detail. I think what's interesting for this project and what I want to mention is that as a company, we want to be able to try different things because we're still developing our business model. We have one business model, which I showed now, which is installing systems in a decentralized way in buildings. But we also want to try, and there is a lot of demand for completely decentralized systems, so where the urine is transported to a place and then handled there. And that's the case with circular bar. So it's a project that's quite interesting that we started this summer. The commissioning happened just a few weeks ago, and so we're still starting up the system. And that's what it looks inside. So it's always kind of the same system. We have different tanks. And here, since it's in a container and the idea was to recycle a container as well, we recycled some tanks as well. So it doesn't look all nice and new as at the ESA system, but it's a kind of a different type, but it works the same. The next one I want to talk about is a quite interesting one because it's not only in one building. So right now I showed you the decentralized within the building, decentralized completely out of a building, and now this is a neighborhood level. In this case, we will treat, this is for now for 2 buildings, but the idea is to be able to add up others over the years when the new buildings will come up in the neighborhood. This is called Blue Factory in Fribourg in Switzerland. And what's also interesting in this project is that we work together with other companies which treat gray water and brown water. So it's not only about urine treatment and recycling, but also having a whole system that works. This is ongoing. So that's what the room will look like for the treatment. You can see on the right picture the different pipes coming from the buildings. So there is the rainwater, there is the gray water, the yellow water, etc. So it is quite a complex infrastructure to have. but it will be a very, very interesting flagship and great project to work in. So that's, that's it for my presentation. And if you have questions, you can shoot them now. And then, unfortunately, I'll need to leave a bit early. So.
Great. Thank you so much, Nadège. And for folks here on site, we do have a bottle of the Urine out there to check out on the break. Take a whiff, but be careful.
Go and smell it.
So as we mentioned,
go and smell it.
As we mentioned, Nadège, you have a little bit of a different time schedule. So there's a couple of questions we'll take from the chat. So maybe just 2 questions. And if there's anybody in the room, go ahead and line up here. So the first question is, how often do you replace the filter, and what happens to used filters? How are they disposed? Can they simply be incinerated, or is it more complicated?
So the activated carbon filter, currently we dimension it for 6 months. We basically try to do everything in order to not have too much logistics. So the idea is that it could be much smaller and we would change it more often, but the idea is to change it every 6 months. And that's usually a filter that's like 120 liters. I know you don't work with liters, but I don't know what your units would be. But yeah, 6 months. And then the treatment afterwards, we don't have enough quantities to recover, so to reactivate it. That's what is done usually in wastewater treatment plants. But in our case, incineration is sufficient, and the heat of incineration is completely sufficient to destroy those organics which go on the filter material. So that's not a problem also environmentally afterwards.
Thank you. And we'll take a question from the room next. Whoever's first.
Are you ready to work in the States? We have a project coming. We have a project coming up with 50 homes with urine diversion that we are piloting on Cape Cod, and that would be the starter. We also have a project where there's going to be affordable housing part of it, and it will eventually be 900 units. Right now, we want to build 300, and they are stuck because of wastewater. We cannot add any more effluent into our system. So all the affordable housing basically on the Cape and any new building is held up because we cannot put any more wastewater in our waters. So
in the system, we have the same problem in that's great. That's we have the same problem in some places in Switzerland and in France as well, with buildings not being able to be built because of the lack of treatment possibility. And so urine diversion is really a great solution for that, for sure. We, I mean, when I speak right now, my colleague actually is in San Francisco at a meeting with different potential clients, etc. So we are interested in the US. We're not quite there yet, and those projects always take a lot of time until they're really being built. And there is also a lot of practical questions in terms of authorizations. The toilets themselves, they're not the same. I mean, very, very basic, which seem to be basic questions, but which still are complex to solve. So it will take, I think, at least 5 years until we're there, but we're definitely interested to come at some point, yes.
And I have one more question.
For now, we need to work closer to us, but yeah.
As far as the composting, it would be good to look into eco drums so that you can compost any materials in a drum instead of on the ground. It would take much less labor, much fewer equipment, and I would like to see that happen soon in some kind of place, maybe even Brattleboro. And if you need any more information, I can give you the contact information for the EcoDrum Corporation.
Yeah, you can gladly also write me an email, so don't hesitate to contact if there are other questions.
So sadly, we do need to move on. I know there's a lot more questions in the room.
Don't hesitate to just write me and then I can answer them. Sorry, I need to leave early as well, so yeah.
So sadly, we do need to move on. There are questions in the chat, Nadège, if you're able to answer those.
Yeah,
and then if
I'll check them.
Minutes at the end. Just want to make sure we get time for questions for everyone.
It's good.
As well.
Thanks a lot.
Thank you so much. Take care. So we'll switch over to Abe Noe-Hays and Kim Nace. Abe is the Chief Technology Officer of Brightwater Tools, which develops technology for productive sanitation particularly for concentrating and sanitizing source-separated urine and vacuum-flushed black water. A lifelong resident of Vermont, he has used alternative sanitation systems since 1976 and has been academically and professionally involved in their development since 2000. First as the owner of a composting toilet business, and then as research director of Rich Earth Institute and CTO of Brightwater Tools. Kim Nace holds an MA in International Administration from World Learning and an MA in Educational Leadership from Keene State College. She was a Peace Corps volunteer in Botswana and has taught children of all ages. She coordinated research funded by the MacArthur Foundation and later served as an elementary school principal in rural Vermont and in Chennai, India. She has been passionate about sustainable sanitation alternatives ever since creating an educational video about composting toilets for her 1989 master's thesis project. As co-founder and executive director of the Rich Earth Institute, she focused her leadership and organizational strengths to build a high-performance team at the Institute and to engage others in the possibilities and practicalities of urine recycling. Kim is now CEO of Rich Earth's spin-off organization, Brightwater Tools.
Hi, good morning and afternoon for people wherever they are. Thank you for that nice introduction, Jamina. Abe and I actually are co-founding this institute and this gathering today, and I'm really proud that we're all still connecting 9 years later. It's a really a wonderful thing to share all this information. So Brightwater Tools, is building the case for decentralized and regenerative sanitation. So we are very interested in distributed water infrastructure. I believe that this, this drawing here is very clear. At the building scale, we need circular solutions. We're going to be working towards water reuse and nutrient recovery. At the building scale, you've seen many drawings during this conference similar to this, which solves a lot of different problems. Our mission is to promote circular economies, providing technologies that facilitate the on-site wastewater nutrient recovery system. We transform high-strength wastewater into a sanitized, concentrated, and purified fertilizer. So we're working with the liquid material. We are developing partnerships also to source, combine, and distribute the relevant components for the full system wastewater solutions. So that means we're talking about the toilets and maybe our technologies combined with other technologies as well.
So to talk a little bit about these technologies, all of our products are focused on treating high-strength wastewater, and that can be source-separated human urine. It can also be vacuum flush toilet black water that has run through an anaerobic digester, or it can be composting toilet leachate. And we have three main products that can be put together in a system or used a la carte. One is a pasteurizer, and that's one the photo there is of our pasteurizer that's currently for sale. We've sold 7 of those and used them at the Rich Earth Institute as well. And that uses heat to destroy pathogens. The freeze concentrator uses so-called freeze distillation or the freeze thaw process to separate a concentrated nutrient solution out from a low-strength effluent. So the nutrient solution can then be purified as fertilizer. And then we are developing a activated charcoal, activated carbon filter, just a conventional system to then strip out any PFAS or pharmaceuticals that may be of concern. And this is a diagram of what we see as maybe one of the highest and most advanced uses of these systems if our products are all put together. As I said, they can be used a la carte, and they are, as the pasteurizer is being used a la carte. But this idea is that you can have coming in from the upper left corner there, either urine from waterless urinals or black water from flush toilets, going through a digester if it's the toilets, then ending up going through the charcoal filtration for the micropollutant removal, then splitting out the fertilizer from the low strength effluent in the block freeze concentration, pasteurizing that product so it can then go to farms or be used on site or by gardeners. And then that low strength effluent can be combined with gray water and treated for on-site reuse, for non-potable reuse. And that as a package has the potential to allow buildings to decouple from the sewer, as others have been talking about here, which can realize some significant savings and also performance benefits. And question, of course, is who pays for this? And we who promote urine diversion often like to emphasize the benefits to society or the environment, but building developers are concerned about their bottom line, and they like those benefits. They don't want to pay extra money so the world can benefit off of their pocket. They need a way that this makes sense for them. economically. And so we have been focusing down through our market research and through a lot of work we've been doing on refining our business model and understanding the market, looking at contexts, and these two contexts particularly stand out. And the first one is where there are limits on nutrient discharge, because obviously taking nutrients out of the wastewater and making fertilizer means they're not in the wastewater anymore, they aren't discharged. And so Cape Cod is the image here. Earl and Hilda here, who have been fighting for decades to get urine diversion on Cape Cod. It's urgently needed for the nitrogen issue there, and it's getting traction. Town of Falmouth has put up money for a pilot study, and that's a place where billions of dollars could be saved by going with urine diversion to save on sewer costs, for instance. The other area is where buildings reuse water on site, because if they have to treat their water on site before it's reused, if we can reduce the strength by taking out urine or all toilet waste, then that simplifies it. And that the Brock Center there in Virginia saved over $300,000 on a sewer connection fee because they don't discharge any of their wastewater. They treat the black water through composting toilets on site, but the same can be done with our arrangement. So zooming out a bit to look at structural economic incentives that these kind of fit in, but what's the bigger picture? A lot of wastewater plants, centralized plants, are maxed out or they can't meet their treatment requirements. Federal funding is not available anymore, and so municipalities bear that economic burden. Therefore, municipalities have an interest in decentralized treatment being built, including decentralized treatment that produces fertilizer. And so there's the potential for municipalities to incentivize decentralized treatment so that overall capacity can grow without the decentralized plant having to invest in ways they're perhaps not prepared to do. So we see these as really the high impact, high potential areas where we don't have to make money off selling the fertilizer. There's economic incentives for adoption for other reasons.
And so I just want to talk a little bit about how the landscape that we are all working within is transitioning. Stakeholders involved in the water industry are waking up and really thinking more seriously about this idea. I know other people I've spoken to in the last few weeks and months have said they've definitely noted a shift in the ability to communicate what we are working on and for people to grab the idea much more quickly. In 2023, the Water Environment Federation created a new task force, which many of us in the room are participating in for distributed water infrastructure. There will be sort of a white paper, or it's not really going to be called a white paper, coming out this year. And that will be distributed widely. So it's a very big step that the Water Environment Federation is saying to the public and saying to its constituents that distributed water is coming down the pike. It's actually also here, like Paula Kehoe from San Francisco is always telling me, the water reuse is happening, and that is part of what facilitates our source separation. The Living Building Challenge this year has also started a new technical advisory group to revamp their water pedal. So they're actually taking a look at what are we saying with living buildings that that is related to the water pedal. How are we going to give different and new credits and points in the living building situation for water, for how water is managed on a building. The Blue Ribbon Commission, which I just referenced, was from San Francisco. They are not only working in San Francisco and California, but many states around the US. And I happen to know that they're also traveling to India and moving this whole water reuse paradigm internationally as well. Matthew and John Lansing and several people have referred in their last session about the codes, how the UPC is looking at how they can take this We Stand code and make it part of the IPC, which will, these are the kinds of important steps that we've all been waiting to have. And of course, we have Fabian here, and these subsidies in Paris are like a lighthouse project for all of us. When Ryan, one of my engineers, and I had the good fortune to go visit there, we were thrilled to get to meet with the actual folks who are providing these subsidies in Paris. And I asked them, how large is the pot of money that you have to support these new projects? And they looked at me a little bit confused because they said, well, we're mandated to do it. So that's an unlimited pot. So I was extremely, So I was extremely excited to hear that information. So finally, I just want to talk about where we are in all of us as these early stage urine processing teams, that we are in competition somewhat, but we are actually collegial and colleagues in these technologies. As we said before, some of our technologies will pair with each other. Most of us are not actually working on the exact same kind of treatment technology. They are trains, and these trains will move and separate, and they can combine. But one of the points of why we went to Europe for 3 weeks and traveled around to see everybody was to build bridges. And I think it's so critical that we build bridges to test each other's technologies, to share case studies and data, like Haley asked for data yesterday, to collaborate on research, to build more partnerships, especially like our last presentation about sharing regulatory language and policy change successes. We need to share that as much as possible, and continue to work together the way we have been for so long. So thank you. That's what Abe and I wanted to share today.
Oh, wonderful. Thank you so much, Kim and Abe. It's so exciting to just, I don't know, I was really feeling in that presentation just how much has happened in the last year alone. And just thinking about what are we going to be talking about next year? And that felt really, really prevalent in that conversation, which was great. So we'll go ahead and move on for Julien Saludas. So Julien is Chief Development and Impact Officer at Toopi Organics, agronomist with 15 years of experience in farmer co-op and agro input companies in France. I believe you are now a co-host.
Thank you for the invitation. It's the third time in a row for us, so thank you for. So I'm Julien. You got my contact on the site, so feel free to contact me if you have any questions. So yeah, first of all, who we are in a nutshell. So we are a young startup, a 4 years old startup in southwest of France called Toopi Organics. We have the chance to run more than 50 trials, innovation prices in the world, in France and also across Europe. The last one was the IC Accelerator, which is really renowned in Europe. We have also raised around 20 million euros since 2019. Our last round was closed in last June, around 16 million euros. 10 years from investors from France, Belgium, and Singapore as well. And we are backed by different other kind of non-dilutive sources of grants and awards in France and Europe. We have a team of 30 people in France and also in Belgium. So mainly agronomists, biotech experts, and we also expect to double by 2025. We've got the first of its class industrial plant of urine fermentations in our outcradle close to Bordeaux in southwest of France, and we expect to build a new facility by 2025 of 1.5 million liters of urine transformed. Our technology is also covered by 4 different patents that are already granted in France and in other countries in Europe and abroad. And we have also put in market the first human-based plant biostimulants in 6 European countries with market approvals. And we also get the organic farming agreements last July. Okay, so on innovation is based on manufacturing urine-based biostimulants. So we, to put it in a nutshell, we collect urine at source in waterless urinals from events mainly, and also music festivals, but also tourist sites and waterway service areas, so also in buildings. I will discuss it further on. We stabilize urine at source by acidification, and then we bring the urine back to your facility where we perform our technologies based on the liquid state fermentation with upstream filtration. So we stabilize urine, we filtrate, we add our carbohydrate sources because, as you will see, we produce microbials biostimulants by adding some specific inoculums of bacteria of agronomic interest. So obviously they need sugar and fermentation and also urine. And afterwards, we package the batch of this urine fermentation in bag-in-box or in cans, and we sell it through the different supply chains of retailers like cooperative, in France, but it could also be retailers abroad in different countries. So the core process is based on the fact that for us, urine is a very interesting and cheap growing medium to do liquid state fermentation. And that's the main difference with other, I will say, technologies existing in the market. For us, urine is not a proper medium to feed crops. However, it's very interesting to feed microorganisms with it. Why? Because obviously you may know that in urine there are a low NPK content, and there you need a lot of capex and opex to concentrate or extract the minerals of interest to produce fertilizers. And obviously there's too low cost effectiveness compared to mineral or organic fertilizers that are already in the market. And you could also have negative externalities because you could generate waste from the process, but you can also generate negative externalities from pollutions, because even if it's based on urine, I would say the farmers will spray or bring nitrogen sources, nitrate and so on, and it could be it could have some consequences or soil pollutions or water leaching and so on. On the other side, urine as a growing medium is very interesting because it's ready to use. You keep everything in urine because water is interesting. Obviously, nitrogen is interesting, and phosphorus and potassium because it's the nutrients used by the bacteria and microorganisms to feed it and to produce biomass and also metabolites of interest. So you keep everything in it. You have also in the urine growth factors. You have also some oligo-elements of interest to do the fermentation. And obviously at the end you have high added value because it's the resultant of the fermentation that is of real importance for us. So using urine is an indirect way of transformation, but finally the product is the results of the fermentation for us. And it's also very eco-friendly because you don't produce any waste, you don't need any water because you use the water already in urine, and you consume a very low energy. The overall process consume 0.35 kilowatt per liter for the first product we put in the market. So we have 3 different actions in our process, which is patented. So we collect urine at source in 3 main partnerships. The main one is even music festivals. We have already collected more than 500,000 liters of urine in 2023 from the main partners, which call Nadège in Europe. So many in France, but also in Belgium, Netherlands, and Spain. We covered lots of music festivals like Hellfest, Saludas, Mysteryland, Rock en Seine. We also equipped 2 different kinds of buildings. The main one is the Futuroscope, which is a theme park in France, with the potential of collect more than 500,000 liters a year. And we also equipped some highway service area, and we should reach the number of 25 highway service area transformed by venting toilets with rudderless urinal in France. And we have also some example of street urinal equipped in Toulouse and also in Bordeaux. Then we bring it back in our facility in Bordeaux. So far we've got a pilot facility with a potential of transforming 250,000 liters a year for our first product, with in-house fats for fermentation, you can see in the pictures, with 5,000 liters of capacity. And finally, a packaging in bag-in-box of 200 liters that we finally sell to our customers. So regarding sales, the business model is based on B2B model to reach farmers through distributors. So in France, but it's also the case in Europe, and also it should be the case also abroad. So we produce everything in our facility so far, which is based again in Bordeaux. We plan to replicate it in other countries in the future. So we hope that the next one will be in Belgium. We propose a product to local distributor like cooperative or retailers, because they're already say their current products to the farmers, so they know the farmers very well. So we absolutely need them to deploy our solutions to farmers. So far we have interesting partnerships with two main partners. So the first one is Califert in France. We already sell around 150,000 liters of products with Califat in France, and we have also sold already 40,000 liters of products in Belgium through our partner SCAM. And finally, we reach the local farmers from the products with cost-effective solutions that are easy to use and are also sustainable, because it's a sort of way to decrease the scope of greenhouse gas emissions and also avoid pollutions and lots of other negative externalities coming from fertilizers uses. So regarding the products, so again, we don't produce fertilizers. We produce solutions that avoid the needs of fertilizers, which is not the same thing. So the first product is called Lactopy Starts. It's based on lactic fermentation of human urine. So again, this product is already approved in 6 European countries and already marketed and sold in France in France and Belgium. So we can use it in numerous crops. We have lots of tests, or around 50 agronomic trials performed in France and Belgium, which were compulsory to get the market approval. So we try to cover lots of different types of crop, but the main ones are field crops and industrial crop as well. And we get, I would say, best efficacy for spring crops like corn, sugar beets, and sunflower as well. So that's our main category. So benefits for farmers, that's an efficient, affordable, and sustainable way to as alternative to chemical fertilizers. Products is easy and very safe. So obviously, because we get market approval, they're easy to store and apply because it's in liquid form. The rate is very low. It's around 25 liters per hectare, which is really easy to handle. And there's no risk to human environment. It's very cost efficient because it's also a way for farmers to decrease the uses of fertilizers. So while reducing their input cost and increasing the margin up to 15%. And it's obviously closed loop and regenerative because it's based on local and renewable natural resources with inexhaustible sources of urine, of course. And it's also a way to improve the soil health by decreasing the volumes of fertilizers they're normally applied on their soils. So the mode of action is based on the inoculum and the type of bacteria we use and the metabolites produced during the fermentation. So the bacterial strains is Lactobacillus paracasei from our strain bank. Okay, so this is a rhizobacteria, and this rhizobacteria has 3 interesting properties to secure early stage vegetative growth and increase nutrient use efficiency. So it helps to solubilize soil phosphorus already present in the soils. So by the presence of this lactic acid bacteria and also the lactic acids, you have, I would say, locally an acidification that could increase the uptake of phosphorus. With the presence of this specific organic acids, you have also a stimulation of root growth that also increases the uptake of water and the nutrients in the vicinity of the rhizosphere. And you also stimulate the mycorrhization, which is a symbiotic association between the crops and also the roots and fungi. And it's also a way to increase the soil exploration and give access to nutrients and water as well. So a set of trials. So for instance, Lactopy Starts in the case of uses in an irrigated maize trials in France. In a picture, you can see some deficiency of phosphorus on these leaves on maize. And by using the products, you can see this, I would say the better shape of the maize because you increase the phosphorus assimilation. On the right part of the slides, you can see the impact of a partial replacement of a so-called DAP, which is a very well-known starter fertilizers used usually in maize, which is also the case in US. And by decreasing the amount of these fertilizers by half and adding the product of our product, Lactopy Starts, with a rate of 25 liters per hectare, you keep the same yield. Also some pictures, examples from Belgium, in this case, again, on corn. You can see some cups, and we have also seen some interesting results coming from using our products as an add-ons to current practices to increase yields without, I would say, putting other fertilizers of chemicals on the crops. And so the case is for soybean, where in this case you have an increase of yields. You improve the yield by keeping the same fertilization, but by adding our lactopistars with a rate of 20 liters per hectare. So finally, our goal is to become a leader in the plant organic biostimulants. In the pipeline, we are currently developing and marketing 3 new products that should meet that. The way is to, our objective is to meet farmers' needs regarding nitrogen as well, phosphorus, but also water stress management. So by using other kind of bacteria consortia, but also other kind of strains, we hope to answer these farmers' needs regarding I would say all the fertilizers issues they have so far. We plan also to collect up to 2 million liters of urine per year, which should allow us to cover up to 600,000 hectares of crop cultivated with urine-based biostimulants in Europe. And finally, we wanted to export in Europe, starting in Belgium and also in Netherlands in the coming years. And also we are also trying to explore the kind of fermentation by, I would say, keeping the same liquid state fermentation. For example, by producing microbial biocontrols to address some specific diseases against some crops, especially corns and also sulfur as well. So this is in the pipeline. Thank you for your listening.
Awesome. Thank you so much, Julien. And just for the whole panel, thank you. That was wonderful. And now we do have some time for questions, which is great. So once again, I know I had to cut people off before, but if we can get some folks back up here, we have about 15 minutes before lunch for time for questions, which is wonderful. For anybody on that panel, and ideally, yeah, for folks that are for this panel specifically would be ideal. So let's start with one from the, and Nadège is not here anymore. That's true. So let's start with this one. Okay. So this is for Julien with Toopi Organics. When you say that the product is easy to use, can you elaborate on the application methods that are used for the product?
So the product is in liquid form, so it's easy to use by spraying the product. It needs sprayers, but conventional farmers usually have kind of sprayers. So it's it's quite easy also to mix with other kind of products at the beginning of the sowing, for instance.
Great. Thank you. We have a question from in person.
My name's Earl Barnhart from Cape Cod. We have lots of nutrients coming onto the Cape, more than we can spread around on the land. We think we're going to have to export it off the Cape. Part of the strategy for one of the speakers is to concentrate it, to make the transport cheaper. The other solution of one of the other participants is to, it doesn't concentrate at all. The Toopi system has as much liquid material at the end as you start with. And so transport is not considered here. And I'm interested in the trade-off between those two methods.
Julien, if you want to start there, and then Abe is coming up to answer from
yes, obviously I can. So obviously we needed to keep, you may understand that we absolutely needed to keep water in it because we also need to keep this liquid form to do fermentation. So we don't have to extract water into distillate or concentrate anything. So we have to transport urine as it is. So obviously you have to transport lots of volume. So that's why we have to collect in the vicinity of the facility to limit the transport charge. And but that doesn't pose any problems. Even in cases of the greenhouse gas emissions, we did an LCA comparison, and we also showed that there's lots of impacts coming from the transport of urine compared to the overall process.
Great. And then Abe, from the folks who are concentrating it.
Thank you. Yeah, in the case of Cape Cod, where the focus is getting all that nitrogen out of the watershed, I think that, that even whether you used it as a biostimulant or as a fertilizer, if you did that locally in the watershed, you'd have the same issue of the total amount of nitrogen, because those, it wouldn't be different whether it was concentrated or not. So if you're trying to remove nitrogen from the watershed, then I think that that concentrating it would reduce the costs of shipping it off. Although I think there are opportunities for replacing fertilizer use on the Cape with urine-derived fertilizer, in which case it could be used locally. And the concentration, I think we see that as useful if either you want to remove urine less frequently from the building or the facility it's being processed in, or you want to transport it a large distance and reduce your transportation costs. So those are the two drivers. And if you're going to just use it locally and don't mind having a large quantity being stored locally, then concentration isn't necessary.
Great. Thank you, Abe. This is from Jenna for Toopi. Amazing that you have approval for organic agriculture. Curious which country and which certification.
So it's called in Europe UAB. So it's the label to sell products in organic farming. So the main, I would say, the main difference is compared to the fertilizers, which is not approved so far, urine-based fertilizers, which are not approved so far in organic farming, is that here we use urine as a growing medium to produce biostimulants, and organic biostimulants so far are mainly old, I would say, approved in organic farming in Europe. So again, the main different thing is that we're using as a growing medium. This is the results of the fermentation that is approved on the market. So this is totally different than I would say sell fertilizers from urine directly without any process. So that's the main difference.
Great, thank you. We have another question from in person, Jane.
Thanks. I have a question for Jenna at Sanitation 360, and that is what's in the cookie dough, and what's the source of that? And I have a couple of little questions. One is, I heard you say it's a nitrogen fertilizer, but I didn't hear where the phosphorus went. And also wondering if biochar could be introduced in the cookie dough at some point, if that seemed like a good thing to do.
Thanks for the question. So we have tried to use biochar in the cookie dough process. Unfortunately, it didn't work. Biochar seemed to be hydrophilic, and we've tested a few different ones. I know that depending on the source of the carbon and how you process it, it really changes that. We have dug deeper into it. So we are open to looking to see if we could practice a little bit more with it. But for some reason, we were not able to get a solid dried product out of it. So we've tested with various different components. You'll hear tomorrow from Luis from Bolivia, and he'll be explaining some of the byproducts in both agriculture and cities that maybe we can find in. And basically, we're just looking for something that we can glue together, because when we concentrate it, we need something solid that is hydrophilic, that then we can get this dried powder at the end, so then we can put it through the pelletizer. In terms of the nutrients, I did focus just on nitrogen, but our fertilizer has everything. So we keep the phosphorus and the potassium and all the micronutrients. We just focus on talking about the nitrogen because that was the achievement that we reached in terms of being able to keep it. So the end fertilizer, it's 15% nitrogen, 2% phosphorus, and 4% potassium. Oh, you're muted.
And what's the carbon source for the cookie dough?
So we are still testing with different ones, and we've used bran, we've used sawdust, and we're looking at other waste products.
Thank you.
Thanks.
Great, thanks. And we'll go ahead and take another one from the room, just because it's a little bit easier to get the questions answered in the chat in the online universe. So let's get a few more from the room. Hilda?
Yeah, it's interesting that we are specifically kind of concentrating on the cost or profit from all these urine products. And in fact, if you look at sewer plants, they only cost money. They never talk about profits. And suddenly we have to have a product that makes profit. Well, why don't we just look at it the same way as we treat sewer plants? Right now on the Cape, there's only 10% of the people are on sewers. So we have a great opportunity on the Cape to do it right from the start. And so we're not looking for making profit from it. So we don't have to really work on exactly how much greenhouse gases go into trucking it X number of miles, because the greenhouse gases are not considered at all in sewer plants. They don't care, they don't have a clue. So we can really start on the Cape as doing it right from the beginning. Another thing is that if we take urine out of the plants of the people that are already in sewers, that makes the sewer plant much more efficient. And that happens then to have an effect on the greenhouse gases, which sewer plants produce a lot of. So I think the urine diversion should be considered not as a profit making, but as a kind of cost reduction for everybody. Right now on the Cape, it costs $100,000 to $110,000 per parcel to connect to a sewer.
Do any of our panelists want to comment on that? Yeah, Jenna, I see your hand.
Yeah, thanks, Hilda. That's a really good point. And it's something that we struggle with, that we get put into this position. And what we see is that for us to have impact at the wastewater treatment plant, we have to scale up so big before we do actually have impact. But as you mentioned, that construction projects are actually being stopped because they cannot connect to the wastewater treatment plant. So we see that incentive coming. And one of the challenges is, even at my house, I'm on the countryside, I'm not connected to a wastewater treatment plant, and we have to put in, we're connected just to an on-site septic system with our neighbor. But there's no incentive to put in a urine diverting system because it will cost more to operate. And so unfortunately, my neighbor is not willing to put in that extra money. So there's still that challenge there, that if we're going to do better, it is going to cost more. But I think your example on Cape Town or Cape Cod is going to become more and more prevalent, because the US or the EU has a new wastewater directive that is going to put more pressure on the wastewater treatment plants, that they have to have better removal of nitrogen. And that's going to be key for us in Europe, that finally urine diverting systems are going to be even more affordable, because the alternative will be too expensive. So we do still need those incentives there in order to drive this change. For the question.
Great, thanks, Jenna. And Julien, I just want to mention that there is a sort of a question in the chat, which maybe you can just answer in the chat and share that. But this is from Christina for Julien. Toopi Organics, could you share peer-reviewed literature? Your results are amazing, so inspiring. Would love to share widely. So that would be wonderful if you can put some literature in the chat. And we'll come back to a question from the room. Thank you.
Okay.
I have one comment about the cost and pricing. I'm from Falmouth on the Cape Cod, and we have we've already priced the cost of urine diversion at $55 million for 800 parcels. That's what our price is, or our cost, whatever you want to think about it. But we have $55 million to divert urine from 800 parcels. So it works out to something like 38,000 per parcel. So that's and that money's available. That's going to be available Monday or Tuesday night of next week. So, you know, we are ready to go. So if anybody, if we can put something together for anything under that figure, we could make it fly.
That's incredible.
Say again?
That's incredible.
Incredible?
Yeah.
Yes, it's incredible. Yeah, it's fantastic. So what? Yeah, so let's go. Now my next question, and I hope to leave here to this summit with, you know, with a package and with a plan, and you know, battle, and boom. Yeah, it's just like, and we're ready to roll. So anyway, my question is, distance versus transportation costs. What, has anybody figured out the distance, versus the concentration and where that cost factor is? Has anybody worked on that? So as my distance increases, what happens, when the concentration increases? Yeah.
Cool, and I think we have Abe coming up to answer that directly. And I think this will be the last question of this panel. Yeah, go ahead.
Thanks for that question. That's not an analysis that we have done in a thorough way, but I think that some relevant facts around that we've found is that that paying a septage hauler to come and pump septage, pump urine, pump whatever, and take it to a wastewater plant. Last time we checked was around 36 cents per gallon, and 10 cents of that went to the wastewater plant to receive it. So if you're just thinking about the cost of hauling, it was around 26 cents to pick up and haul and discharge that somewhere nearby. I think that if you went with a bigger truck, and you're doing large amounts, then it'd probably be less per gallon. If you're going a long distance, it'd be more per gallon. So that's not a figure to quote on like, this is what it would cost to transport urine in any particular situation. But the operating cost, this is not including capital costs, but the operating cost of freeze concentration is on the order of a couple. We don't have a hard figure on that yet because we're still dialing in the efficiency, but around a couple cents per gallon for concentration. And that is also a number to please not, don't use that as a basis for anything. It's just a comparison, whether it's 1 cent or 2 cents or whatever it is, it's much lower than the cost of hauling. So if you do have to transport it by a commercial hauler, the operating expense of concentration would be lower. We haven't factored in the capital expense. So it's not a complete equation, but that's why we're very interested in it, because that hauling fee is much higher by comparison if you're doing a lot of urine in an ongoing way.
Great. Awesome. Thank you, Abe. Thanks for that question. So that brings us to the end of this panel. And of course, keep an eye on that contact list. I think there's a lot of folks who have a lot more questions, and reach out to people, keep these conversations going. This is just to start the conversation. So don't let this be the end.